So, with all this talk about the undeniable probability of alien existence, some might wonder, where are they? Why haven't we seen them? Where is the evidence? In the summer of 1950, nuclear physicist and inventor of the nuclear reactor Enrico Fermi asked the same questions to fellow physicists during a casual luncheon. According to a March 1985 report by the Los Alamos Technical Associates, the four physicists were discussing their disbelief in recent UFO sightings when Fermi suddenly blurted out, "But where are they?" Everyone at the table laughed because even though his question was out of the blue, they all knew he was talking about extraterrestrial intelligent life. They concluded with the vastness of space, the distance between intelligent civilizations is too great. Soon thereafter, Fermi did his own calculations and concluded that we should have been visited by aliens many times over. No credible evidence of intelligent life other than Earth exists. This was later coined the Fermi paradox, the contradiction between high estimates and zero evidence. A more diligent analysis was later published in the 1975 Journal of the Royal Astronomical Society that has some compelling premises that still hold weight today. The line of reasoning goes: first, billions of stars like our sun probably exist in the Milky Way galaxy. Second, some of these stars invariably have planets like Earth that may have developed intelligent life. Third, if they live long enough, they should have developed interstellar travel, which is something we continue to explore. Fourth, over the course of millions of years, intelligent life could colonize the galaxy. Fifth, and since stars live billions of years, the galaxy could be easily colonized. So according to this argument, we should have seen visitors by now. But Frank Drake, who is the founder of the Search for Extraterrestrial Intelligence and writer of the famous Drake equation, explains Fermi's head was in the right place, but like so many of us, we've been led astray. Drake believes that we've been misled by science fiction, which makes space travel look so easy. But the reason we haven't seen anyone is simple physics gets in the way. First, the closest Earth-like planet, Proxima Centauri b, is 4.2 light years away. So traveling at 1/10 the speed of light, it would take 40 years to get there. Hitting a space pebble at that speed would release the destructive energy greater than a nuclear explosion. This would also take much energy. This would also take too much energy at that speed. Drake explains it would take the equivalent of 80 years of the United States energy usage to get there. All these things do need to be worked out, is what he's trying to say. This is his argument. Intelligent species realize that this energy could be put to a better use. His claim is that we are only trying to gather information, which is what other intelligent beings would do. And this can be done with radio and light waves, which is much more cost effective. Drake also doesn't buy into the self-replicating probe hypothesis called von Neumann probes. The 1980 Journal of the British Interplanetary Society explains that self-replicating von Neumann probes could explore the galaxy at a fraction of the cost. These probes could travel to other planets, self-replicate, travel to another planet, rinse, recycle, and repeat. This is kind of a technological panspermia. Drake claims an intelligent species wouldn't do this because of the potential hazards. These probes could malfunction and self-replicate until the galaxy is filled with nothing but space probes. And if they became aggressive, it'd be difficult to stop a countless army of these probes. Drake chose to counter these points because this argument was used in the Frank Tipler updated analysis of the Fermi paradox, published in the 2007 International Journal of Astrobiology. Physicist and cosmologist Frank Tipler would point out that Drake is putting a limit on what we can accomplish, and he's committing a kind of logical fallacy called the anthropic principle. At its core, the anthropic principle says that any data that we collect must be compatible with human perceptions. The result is that we often make assumptions about the universe based on the fact that humans exist. So, for example, we could say, well, human life evolved on this planet, so it seems fairly easy for intelligent life to evolve elsewhere. This is a bad thing for the Drake equation because it makes estimating the probability of intelligent life evolving difficult. Tipler points out in his paper that some prominent Evolutionary biologists disagree with the notion that intelligent life exists in the known universe because the chances are just too high. Frank Ayala at UCI estimates that the chances are 10 to the minus 1 million. This raises the question, does this make the Fermi argument less of a paradox because one conflicting argument is less compelling? One thing is for certain, the universe is unfathomably large, and to say that intelligent life doesn't exist elsewhere seems short-sighted. The principle of our intelligence compels us to gather more information. Because of this, we will and must continue to look for life beyond our home planet.